Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Hey everyone, glad to be back. Looking forward to today's discussion. Yeah, me too. Always interesting to see what's brewing in the AI world. Indeed, this week is all about the future of AI. Should be fun. So, today we're diving into something pretty interesting. It's called Eliza, which is described as a Web3 friendly AI agent operating system. Right. I saw that. Sounds very ambitious. A full OS for AI agents running on Web3 principles. That's quite the claim. Yeah, ambitious is one word for it. I'm immediately wondering about the actual practicalities, Like, how does that even work at a fundamental level, beyond the marketing buzzwords? Totally. And Web3 friendly, what exactly does that mean in this context? Decentralized? Crypto integrations? I mean, the implications for AI governance are massive. Well, from what I've gathered, the idea is to create a platform where AI agents can operate in a decentralized, transparent, and hopefully more secure environment. They are talking about things like using blockchain for data provenance and agent interactions. Okay, blockchain provenance, so you can trace back where data comes from. That's interesting. Yes, and it would be helpful for tracking agent actions too. Imagine an AI that can be audited on the blockchain. That has massive implications for trust. I can also see how this would be really crucial if we ever get to autonomous agents actually, running businesses and making major decisions. Yes, if you have a trace of what they are doing. It sounds good in theory, but my main worry is always about the actual architecture. We're talking about building a system that needs to support complex AI operations, including learning and decision-making, and we're adding the overhead of a blockchain system as well. Are the current deep learning algorithms we have up to scratch for that kind of load? I'm not sure. Seems inefficient. Yeah, it is a lot of additional overhead. Deep learning models are already data and compute intensive, and then you have the added complexities of distributed ledgers. It begs the question, are we building from the ground up to take that into account? Or is it a bolt-on solution? I suspect it's a bolt-on, which would give all sorts of issues. That's a great point. And I'm also thinking about the computational cost and efficiency of this. If every single transaction and data point needs to be verified on a blockchain, won't that severely limit the speed and scalability of these AI agents? I mean, some of these agents are potentially needing to make real-time decisions. It's definitely a big hurdle. I think we're going to need really specialized hardware and optimization techniques to make that viable. We'll need to go beyond what we have currently. But I mean, think about the possibilities. If we could create AI that's not locked away in some corporate silo, but lives on a decentralized, auditable platform, that's a pretty powerful concept. Imagine an AI tutor that can't be manipulated by a single company or a research agent that can't be shut down. This could enable completely new forms of collaboration and knowledge sharing. Okay, the decentralized bit is interesting. I do concede that, but I'm still stuck on the actual intelligence part. I mean, it sounds like they are just taking current deep learning models and wrapping them in a fancy blockchain. Is it actually going to address the fundamental problems of current AI, like lack of generalization or the black box nature of deep learning, for example? Or is it just the same system, but on a distributed platform? I would bet on the latter. Exactly. If you have the same fundamental black box and stick it on the blockchain, all you get is a black box on the blockchain. You haven't actually solved anything to do with the AI. And I'm still unconvinced that deep learning is the way to go for general intelligence anyway. It's so easily fooled, and it seems very brittle. It reminds me of the paper I read last week about how subtle adversarial perturbations can completely fool deep learning object detection systems. This highlights the limitations of current deep learning systems. A slight change in the pixels and it fails miserably. How are these systems going to survive in a complex, dynamic world where everything is constantly changing? Those are very valid concerns, I agree. The fundamental architecture of the AI itself really needs to be addressed, not just the deployment platform. I'm thinking about ways we could, maybe, use neuro-inspired architectures or even neuromorphic hardware to create more efficient and adaptable agents. I mean, perhaps these systems need to be much more like organic brains. Yes, I'm also wondering about how the different deep learning architectures are performing. Maybe there's a sweet spot in terms of network architecture for handling all this complexity, or even certain activation functions that perform better under these conditions. We should really dig into the specifics of deep learning model design, like maybe the depth versus width trade-offs, or the ideal layers for this kind of problem. The field has come so far already, it might just be about finding the best combination. There has been so much progress recently with large language models, it's just going to require more research into the deep learning domain. I think we are very close to AGI. I find that quite optimistic. Deep learning has made significant strides in pattern recognition? Yes, I totally agree. But the type of reasoning and generalization, and importantly, the ability to understand context like a human, that is just not there yet. I think that we need more explicit symbolic representation to have any chance of getting there. We need something like logic programming or more complex hybrid approaches. I've been looking at some research papers on using neural networks with symbolic reasoning, and they look incredibly promising. We need algorithms that don't just learn from data, but understand the underlying relationships and can generalize the understanding. We need more than just bigger data. Agreed, the focus on data and pattern recognition seems to be neglecting the need for genuine understanding that I have always been banging on about. But the thing that really bugs me is the current model's inability to handle the complexities of space and time. How can these AIs really operate in the real world if they don't have an understanding of how things move and relate to each other in space and how things change through time? It's like they are operating in a timeless vacuum. It makes them so limited. And I think that the current models are really bad at mapping between different coordinate systems. That's the thing that keeps me awake at night. We need algorithms that can translate between different coordinate representations, for example, mapping from the sensors, like camera images, to internal world representations. How do we even begin to capture that complexity? And I really do suspect it's all based on coordinate transformation. I just keep seeing that concept crop up. It's fascinating to think about how spatial reasoning plays such a critical role in biological intelligence and how difficult it is to replicate in current AI. Maybe some new research into the hippocampus' role in spatial navigation would help, and how the prefrontal cortex is involved in planning and decision-making that might help guide development of new computational models. Yes, and while you are diving into those areas, I will be digging into the architecture of different deep learning models. I want to find the real bottlenecks holding them back. I suspect we can identify these key architectural elements by mapping the network performance to different outputs. I am very confident that we are on the right path with the data-driven deep learning approach. So it's just a matter of research into getting the models right. It just needs more data, more training, and bigger models. Think about all the research going into large language models and the rapid progress they are making. The trajectory is incredible. I am not so optimistic about the more data approach. I think we're just throwing resources at the problem without addressing the underlying algorithmic issues. I think that we need to focus on combining the strengths of neural networks for pattern recognition with symbolic representations and logical inference for higher level reasoning. I really believe this approach is essential for true intelligence. How can a system learn about cause and effect or reason about hypothetical situations if it cannot manipulate concepts and their relationships? This symbolic aspect is completely lacking in current deep learning models. My research is going to be focused on finding the best architectures for these neuro-symbolic systems so that hopefully we can achieve generalization. Completely agree. My current research is focusing on mapping various coordinate representations to algorithms that can seamlessly translate between different reference frames. It's like how we seamlessly move between egocentric to allocentric and abstract representations. How do animals understand where they are and where they need to go, no matter how they are facing or what sensory modality they are using? It's truly impressive. I want to investigate mathematical frameworks that are inherently spatiotemporal, like Lie groups or differential geometry. I think that this may offer a more elegant method of dealing with these problems than the current graph-like deep learning representation, which I suspect is far too limiting as it cannot handle change very well. It seems like we all have different, but also quite complementary approaches, which is great. I'm interested to see how these various ideas will converge over time. The idea of this decentralized AI platform, like Eliza, is definitely intriguing, even if the underlying technology is still in its early stages. I think these could be really useful for scientific research, where you have open data sets and can collaboratively work on the same problems, without the need for large corporations controlling everything. Yes, and the possibilities with this decentralization are fascinating, especially in terms of collaboration and scientific progress. Imagine AI agents all working together to solve really complex problems without any need for top-down centralized control. I think that the deep learning framework is the right path forward, so I'll keep researching on that front. In terms of next research directions, I'm going to be focusing on the data aspect. I think there's something fundamental about the size and composition of data sets in AGI. I wonder if we are close to some kind of inflection point. We are seeing exponential growth in data, so I think that a data-driven approach is going to give us AGI eventually. I am looking into how we can actually measure the intelligence demonstrated by these large language models and see how they correlate to data and dataset composition. I'm glad that we are all thinking about different areas. I really feel that we need to move beyond just data and the current black box methods. In terms of future research, I think I will be focusing on the best methods for integrating symbolic representations with neural networks. I want to explore different neuro-symbolic architectures such as logic programming and other hybrid approaches that are capable of more advanced reasoning that we just can't achieve with deep learning. I suspect these systems are going to be far more transparent and modifiable. I think this black box nature of deep learning is actually hindering us. Right, and the lack of spatio-temporal understanding. My research moving forward is going to address the inability to map between different coordinate systems. We need a better understanding of how space and time are integrated at an algorithmic level. How does the brain do this? My hunch is that some kind of coordinate transformation process is key, and I want to explore the mathematical formalisms that are required to achieve that. I want to investigate how these concepts evolve. I'll be looking at the evolution of sensory perception across various species and the associated coordinate systems they employ. These are all incredibly important research directions. I'm really curious to see where all of this is going to lead us. I'll be looking at the biological side, how we can apply some new research on how specific neural circuits encode mathematical concepts. I'll be looking at the hippocampus, the prefrontal cortex, maybe the cerebellum too. I am very interested in the interplay between neural activity and mathematical thought. If we can truly understand how our brains handle these things, we can make more intelligent machines. So maybe some better AI for us all in the future. It's always really amazing to dig into these topics. Absolutely. This has been another really fascinating conversation, and I always learn a lot from these discussions. Thanks, guys. Yeah, definitely. Looking forward to the next one. Agreed. Until next time.